In this video, I'll show you the Taylor series formula and I'll work through an example. A Taylor series is a way to approximate a function with a series of polynomial functions. In other words, you're creating a function from lots of other smaller functions. As a simple example, you can create the number 10 from smaller numbers like 1, 2, 3 and 4. In the same way, you can piece together simple polynomials to create a more complicated function. Why would you want to do this? In many cases, you know what a function looks like on a graph, but you don't know the equation for it. The Taylor series can create a duplicate that's so close to the real thing you won't be able to tell the difference. Taylor polynomials can approximate a function around any value for a differentiable function. The formula looks a little ugly, but if you break it down into small steps, it's a very fast way to approximate a function. Let's use Taylor polynomials to approximate cosine x around the point x equals 2. In the first step, we're just going to evaluate this part of the polynomial. The function f of c, we're evaluating cosine of x at x equals 2. So if we plug in cosine 2 to the function, we get cosine 2. The next step, we're going to move on to the second part of the Taylor polynomial. For that, we need the first derivative of cosine of 2. By definition, that's negative sine of 2. When we plug that into the formula, it simplifies to negative sine of 2, x minus 2. In this next step, we want the third part of the Taylor polynomial. For this, we're taking the second derivative. In other words, we take the derivative of step 2 and place that over 2 factorial. That simplifies to this expression. I'm going to do one more step, and that's to find the third derivative. We're finding the derivative of step 3, and that's all over 3 factorial. That gives us this expression. You could continue evaluating more pieces of the Taylor polynomial, but for this example, let's stop at 4, and we're going to add all of the parts from step 1 to 4. That gives us a new function that we can graph. This is what the fourth iteration looks like on a graph. I graphed this with Desmos.com. I've also plotted the original function, which was cosine of x. This gives us a very good approximation around x equals 2. In fact, it's so close, you can't tell the difference with the naked eye. You could go on forever with iterations of the polynomial, but usually 5 or 6 is good enough for an approximation. I hope you found the video helpful. Please take a moment to subscribe to my channel, and I'll see you in the next video.